The Geoscience Collection of the University of Bremen presents A Geological Journey Through Bremen, Episode 1. A Whole Lot of Grains. The Olbenkirchen Sandstone, famous for its career in the building of many important buildings worldwide, comes from near Olbenkirchen, near Buckerberg, in the Hanover region of northern Germany. It has a long history, not only geologically but also historically. The sandstone formed around 143 million years ago in the oldest stage of the early Cretaceous, known as the Berriasian. You might know some of the characteristic Cretaceous life forms, including the dinosaur Iguanodon, which we will see in the film Storms of the Dinosaur Era. During the Berriasian, northern Germany was largely an area of continental plains and inland seas. Beach areas and sand barriers characterized the formational settings of the Wealden sandstones, one of which was the Olbenkirchen Sandstone. Olbenkirchen was located on the edge of a shallow lagoonal sea area at the time, and the climate was subtropical, with humid seasons being interrupted by drier seasons. Evidence of shallow seafloor processes and life can be seen in the sandstone in the form of oscillation and ripple marks, shell and plant indentation and trace fossils. Plant, shell and animal carcass material was transported in the river systems of these regions and can also be found in the sandstone. In the film Fossils of the Bremer Stone, we will see exactly which kinds of animals were around back then. So what is the Olbenkirchen sandstone comprised of? If we look closely at the surface of the rock, we see very small crystals. These crystals are predominantly the minerals quartz, comprising 90 to 95% of the rock, together with mica, plagioclase and titanite. The grains of the sandstone are fine, being from 0.125 to 0.250 millimeters in diameter, and tightly packed with a natural cement holding them together. These minerals were the main ingredients in the formation of the sandstone. How did these loose grains become packed together to form a sandstone? Over time, the sand of the sand barriers, also called sand islands, were consolidated into sandstone. Pressure, dissolution, resolution, and recrystallization were the main processes leading to this consolidation, or diagenesis as a geologist calls it. After diagenesis, the rock underwent changes in appearance, specifically in colour. Because of the porosity and permeability of the rock, water can freely percolate through it. The water-containing elements such as iron, in the form of limonite and hematite, could thus change the colour of the rock into reddish browns, black and yellow, and all in a concentric way. These concentric ring-shaped colour variations were named Liesegang rings, after the chemist who first described them. So now we know how the Olbenkirchen sandstone formed, and what it is made of. In our next film of the short film series, A Geological Journey Through Bremen, we will discover why this particular building stone became so famous and important, not only in Bremen but worldwide. Stay tuned for A Building Stone Makes a Career.